to you.
So just a small bit of housekeeping before we start. We're not anticipating a fire alarm to go off, so if it does sound, we just all need to vacate the building the way that we came in. Go outside and obviously await the all clear to come back in. Toilets, if you haven't spotted them, and feel free to get up and move around even though it is being recorded. Back out the way you came and then back down the corridor on the left hand side. And then moving on to the agenda. Thank you. So we're going to start this evening with a very short introduction from our recently appointed portfolio holder for climate change and strategic regeneration, Councillor Simon Curry. And then we'll move on to part one of the information session, which will look at why it's important to consider the fabric of your building and the suitability of materials when making improvements to your property. That'll be followed by a short 10-minute break, and then we'll gather back again around 10 to 7. And we'll have a slightly longer session for part two, which will go into detail around some of the things you can do in your homes, like heating, cooling, renewables, smart systems, and some quick wins as well. On top of this, we've set time aside for you to ask questions of our colleagues at the university. We have got a lot of information to get through, so we kindly ask that you do save your questions until that portion of the evening. We've also set aside a few minutes to just hear your feedback from you. We've got a form for you to fill out if you're happy to do so, just to kind of find out your feedback on the event and also where you are on your personal journey as well. Hopefully, please do join us. That's okay. That's all right.
Yeah.
So I'm just kind of running through a brief agenda for the evening. So yeah, as mentioned, some photos will be taken this evening. Obviously, if you prefer not to be captured in those photos, just to help us promote future events, just let myself or my colleague Daniel know. And finally, as we mentioned, we'll also be filming this session. Those of you that have just arrived in the front row will be visible from the back of your head. So if you prefer not to be featured in the recording, then there's an opportunity to sort of move further back. Finally, just a gentle reminder to silence your phones, and then I'll introduce you to Councillor Simon Curry. Thank you.
Right. Good evening, everyone, and thank you for coming along. It's quite warmy. Oh, do come in. But thank you so much for coming along this evening. There's a couple of familiar faces out here, so people, excuse those who know me. I'll just say a bit about who I am and what we're trying to do as Medway Council. I started life here in Medway back in 1987, running the country park at Capstan. So my background is in ecology and countryside management and environmental management generally. And since May, the Labour Group has taken over Medway Council, and one of the things we've done is put climate change at the heart of all our policies. That's a really fundamental message that we're trying to get out to the whole community in Medway, is that climate change and the action that we need to take has to be at the centre of everything we do. And that's why we're here this evening. It's a cross-cutting policy. We're covering biodiversity and air pollution and the pollution in the river and our contribution to the national climate targets. All that comes into play when we say we're putting climate change. And energy is one of the things that really matters a huge amount, and you'll hear a lot about that this evening. So welcome tonight. I'm sure your motivations for coming here this evening are your own and unique, and maybe you're involved in the industry, or maybe you're just trying to make changes in your own home, or you've already made changes. You want to see if they're the right ones that you've made and you've spent the money in the right direction. So I'm sure you'll hear more about that. But whether you're getting started or just looking for more accurate and detailed information, I'm sure tonight's event will really give you what you want. It's aimed at helping reach our target of 2050, but it'd be great if we had a target of 2030 or 2040 instead, but 2050 is what the government's chosen, so we're going for that at the moment. So bearing in mind that our homes are about 40% of the emissions across the country, alongside cars and vehicles and transport and industry and stuff, homes is a huge amount of what we put into the atmosphere in terms of heat and pollution and stuff like that. So this is hugely important work that's being done to get the message out there as much as we possibly can. So thanks to Mohammed and to Wim for coming along this evening, and I hope you'll learn a lot about it. And there'll be questions afterwards. So I'll hand you over. Thank you very much.
Right, thank you. So I'm Wim Mellis. I'm going to set the very quick scene of why bother, to be honest, and then I'm going to hand over to Mohammed in a second. So this is the outline of what we're going to be covering. This is before the break, and that's the bits after the break. And there are some funny animal pictures somewhere in between if you're lucky. So just very quickly, a bit of a disclaimer. The reason we're doing this, we're living in a society where nearly anything you say will be used against you. This is not why we're here tonight. We're here tonight to give you information from our backgrounds. We want to help you understand how you can, improve your property. That's why we're here. We will at some point maybe mention some brand names. That doesn't mean that those are the only solutions. There may be other solutions out there. Yeah. So I will mention a few brand names just to kind of put similarity to what people may be aware of what they've seen. And that's the only reason we've got them there. So why do anything is the first question. Well, it's not my quote, but a number of people have already been saying doing something will cost money, doing nothing is likely to cost a lot more in the long run. So if that isn't a motivation, then I don't know really. Some people will look at it from a very financial perspective, and then the question is, how much more is my property going to be valued if I come up with, or put specific things in place for that property? And we can see some figures here on the right. So solar panels and insulation, or let's say the two main topics that people have wanted to see changing to that particular property, and how that changes the actual property's values. We'll take questions at the end if you don't mind.
Are you putting these to pack out later?
Yes, we are recording everything tonight, so you will get that recording later. So another reason is improving your standard of living, because at the end of the day, it's your home. You spend a lot of time in there, and it's really, making sure that you get a better experience as you spend that time in the property. It's the right thing to do. There are reasons not only from a carbon perspective, there are a lot of other reasons. And in many cases, it will save you money in the long run as well. Not to mention, and we've heard some of that at the very start, policy updates. If you look across the globe, we can see policy updates coming that are probably going to be reflected at some point in the UK as well. So we are going to see some of those changes coming along. So what does ideal look like? Some of you in the room have probably heard of Passive House. There is now 3 different standards there. There's Classic, Plus and Premium, which you can find at the right bottom there. The main difference between them is how much energy you are generating versus how much you are actually consuming. And so that's very nice if you're thinking about new build. Most people have what I would call the retrofit challenge. You've got a property, you want to improve upon it. And the question then is, how far can you go and how do you do it? And that's our main remit of the session tonight as well. So from a standards perspective, 2 things to mention. There is a retrofit equivalent of Passive House, which is called Enepit. And the aim or the difference with that specific standard is that it takes into account that there may be limitations to what you can do to your property. You live in a conservation area, you may not be able to change things outside. External insulation is therefore out of the question. Some other changes may be out of the question, like changing your windows if you're in a grey listed building and so on and so forth. So it takes this into account and is trying to get you to the best possible standard for that particular building. Yeah. 2 other to mention, and these are actually 2 different levels, but they come from the Association of Environment Conscious Building. That's a UK-based association, whereas Passive House is an international standard. There's 2 different levels. The idea is that you can build up to level 1, and then from there you can build up to the next level. The checking, I would say the certification is probably a bit less rigorous on this one than it is on that one. Enepit Passive House normally comes with the requirement of getting that certified, which means you get people in, you've got to pay them, and then you get the certification at the end of it. Yeah, that's part of the process. So, building fabric. Over to Mohammed.
Thank you. Hello, everyone. I'm Mohammed, and I want to talk to you about the building fabric. First of all, I like old buildings, and I think old buildings are the example of sustainable building because most of them, they have been designed in a way to interact with the environment around them, and also they have been designed and constructed using the local material and also the local craftspeople who are working in that area. So it's very important to understand how a building has been developed to respond to a specific site condition before you kind of like embark on any retrofitting. So one of the things is that I want to mention is to understand your experience of living in a building before you start doing something or doing some monitoring. So you cannot really start retrofitting without understanding the building. So either go through the surveying, monitoring, or use your experience of living, especially if you have, recently purchased a property and you want to go through a retrofitting. Use your experience to see what's happening, what's going on with the building, then try to actually find the solution for it. The other kind of thing that before you start your retrofit journey is to consider the building as a whole. So the building is like a machine that is working, together. So you cannot really just jump on one specific thing and fix that one without considering the effect and the impact that fixing is going to have on other aspects of the building. Consider the future of the building as well. So what are you trying to actually do later? Are you going to add extension? Maybe next year you want to add extension or you're planning to do that. So consider the future kind of like aspects of your plan. For instance, if you have problem with your windows and you just go with solar panels, so you're not really considering the building as a whole because you're losing the heat through the windows and the solar panels is not really going to help you. So you consider the building as a whole before you make any decisions. So this is one of the examples of thinking about the future. So they are, in this scenario, they're thinking about the thermal collector, but they haven't installed it, but they installed the piping for it. So maybe they haven't had enough money now to just go for it, but at some point they realize, okay, we're going to add that. So while we are doing this construction, let's just put the pipes because it's easier, it's cheaper to do it now, and maybe in a couple of years we're going to introduce a new system. This is the way that you think about a building as a whole and the future plans. So maybe later stages you want to add some other kind of technology to your building. I want to just quickly go through two important kind of concepts here. One of them is, breathability, how the building is breathed, and air permeability. So sometimes when we're talking, a building has to breathe. We're not talking about actually air, we're talking about water, we're talking about vapor, we're talking about how water is going to kind of go through the fabric. And when we're talking about air, we're talking about air permeability. And that is that this fabric, how this is going to actually work in terms of allowing the water to pass through it or allowing the air to pass through it. Is it going to be resistance against water? Is it going to allow water to pass through it? So this is very important, especially when you start looking at the building and you want to start understand the building. So you're looking at a solid wall, solid brick wall here, and as you can see, that's the ground here, and it's a very easy kind of structure. So this specific kind of structure, it allows humidity to pass through the fabric, so it works with the environment. This ground allows to absorb the the water, the excessive water that it has. So this kind of like a facade, it allows the water to evaporate. Okay? So that means that this specific structure and detail is going to work with the environment around it. So let's see if we just introduce some measures without understanding. So here we just added this concrete slab, we added some plaster, so moisture kind of like a resistant plaster, and also concrete pads, here. So what is going to happen is that, so the moisture, the damp, okay, is going to find its way. Water is going to find its way. So, and this water, because of this concrete, and concrete doesn't really allow evaporation, it goes through the structure of this wall. So all the water that is coming here, it goes all the way through it. And when you realize that, when you go through refurbishment, you realize that, okay, there are some problem here, when you scrap it, you go, what's happening? What's happening with this foundation? Because you created a situation that is going to trap the water here. So that hard, plaster that is not going to breathe it's not going to allow the water to pass through the structure. So these are some measures that has been introduced in the past, and we have seen that they created problems instead of kind of like making the building better, because generally speaking, we want these old buildings to breathe. That means that they can kind of like carry certain level of water, and some kind of like a cement-based render and plastic membrane, maybe they are not the best options here. So having a look at a different structure, we're just going to kind of like look at to see how we can understand breathability. So this is a kind of like another kind of like example of a 19th century brick building. You can find it in many kind of like buildings with suspended timber flooring. So here, this air kind of like brick, it's going to actually provide ventilation for this. That means that the water here, is not going to be trapped and find its way through the wall. So this is very important. I have seen that many buildings, they started kind of covering that. They put something. So that means that you're trying, the building is trying to breathe, and you're just going to suffocate that building. And the water is going to stay here because it cannot evaporate. You just block the ventilation for it. Okay? So again, this kind of like a brick wall is going to, absorb this water and then evaporate it, give it back to the environment. So having a look at a modern cavity wall, so a completely different kind of like a principle here in a modern cavity wall. So here we have the concrete slab, but what we have is that now we have a damp-proof layer here, this side. So this damp-proof layer is going to prevent the water to come through the foundation and find its way all the way to the building. So this is working on a different principle. So it's very important to understand how this fabric is working before you introduce any measures to improve it. So one of the problems that we have with water, it would be condensation. So condensation is happening when, because air can actually contain more water. So when that warm air is going to hit a colder surface, then it's going to lose the water. It can carry a certain amount of water. And you have seen this in bathrooms when you are kind of like getting showered. So this is the visible one. You understand it? It's easy. But the problem that we have, the invisible one, that is happening inside these layers of the fabric. So you heat up the building. That's okay, you're good. So that air is going to pass through the wall and it's going to hit a cold layer inside the wall. And it's going to condensate inside the wall. That's how black mold happening behind the wall. You don't see it. It's not visible. It's happening in the inner layer. If you block the kind of like the way that the fabric is going to breathe, condensation is going to happen inside. And we have seen it in some properties. It's going to create problem with the air quality. And when you scrap the wall, you're going to see black mold happening behind it. So that's the condensation inside. So because the water has to pass through the material. Okay, so some of the stuff when we're talking about like introducing measures that are not good is one of them to fill in the cavity with foam insulation. So this has to be done very, very carefully, without kind of like having a proper monitoring, without having a kind of like a good understanding of the fabric is going to create one kind of like a layer inside that is going to create condensation and is going to kind of like create more problems basically. And sometimes these measures, they have to be introduced very, very carefully. In that scenario, this is the wrong version of it because you shouldn't really look at to kind of like put the holes inside the brick. You have to look at the mortar because the way that the foam is working, they have different, capacities in terms of allowing to absorb the insulation. And you're going to see that there are going to be some patches, inside, hidden. You cannot see them. And then it's very hard to identify these patches and then fill them up. So anything that is going to be a fixed kind of measures, you have to be very careful. Because you can't know, with something like this, you have to be very careful about that. You cannot change it. You cannot just go back and say, okay, I want this cavity wall to bring it back. I don't want the filled insulation. So think about that. Any kind of like measures that you cannot, bring it back, think twice before you introduce it to your building. So now we're talking about air. So we talk about water. Water is going to find its way. Even through the smallest crack, it's going to find its own way. And it's going to create some damage. Same for air. So air is going to also find its own way. Even when you have a very, very tiny, small kind of like opening, that sometimes you can easily neglect it. It's going to find its own way to kind of like to your building or in terms of hot air outside your building. So windows are, generally speaking, are the weakest kind of point of contact that we have. So if you think about a building as a submarine, so windows are the weakest kind of point of contact, and we have to kind of like make sure that we take care of them properly because with stuff like that, with the rot like that, so it's going to create air leakage, and we're going to lose the precious warm air through them. So even smaller cracks, they have to be fixed. The way that we can understand this is to run an air tightness test. So an air tightness test is going to close the building, and one door they put this fan and they pressurize the building to see how much air you're losing, based on every hour per cubical meter. So one thing that you can kind of like do is that this is kind of like a smoke pen. So a very affordable that you can find, or if you have some kind of like anything else that makes the smoke. So on drafty days, you can just go around, around the windows, floorboards, to see where you are kind of like losing air. Because the draft is coming through the building, and this smoke is going to show you how you kind of like a little test that you could kind of do that. Even around the pipes that, the radiator's pipe that's coming through the floorboard. So you're losing some air through there. So this test is going to tell you about your building. So it's something that you can do to understand what's happening. So one of the things that we have to do we have to look at the air tightness. So the air tightness is not the same as breathability. Breathability, that's all about water. So this is about actually air and how we can actually look at it. So the air tightness membranes are very important, and so they have been designed, as you can see here, in a very kind of like a thin film kind of like a shape, and they have been designed to specifically keep the air inside here in this scenario. So again, we're thinking about building a submarine. So anywhere around that, you have to airtight it to the best that you can do. So draft proofing, I think that's the first measure that you have to introduce to the building before jumping to any kind of like a more expensive kind of things that you have to, because that's the first thing that you're losing, heat, and the first kind of like a line of defense. And we are talking about, generally speaking, in the UK, the construction is not very good in terms of air tightness. And we're talking about extreme measures that sometimes you if I tell you, you're going to laugh. That's something that, what is happening with your letterbox? I mean, is it kind of completely going to close, or is it loose and the wind is coming through it and you're losing, something like that. So as simple as that, this is the extreme that you have to go to think about how you're going to airtight your building. So this is the tape, the special tape that they have to use, contractors they have to use when you put these two boards together. You see, this is the crack that we're talking about. This is the level of airtightness that we want. So they're just trying to kind of like even go through that crack, a couple of millimeters crack between these two boards that are kind of like meeting each other. So all the pipes that are kind of like coming through the wall or passing through it, this is one of the things that people usually just completely neglect that, and you can see it. Radiators part, nothing around them, completely just put a hole in the floor, pass over. So they all have to be airtight with the proper material, with the tape around them to make sure that there is no kind of like a gap. One of the things that you have to consider in terms of like air tightness, again, so I told you about the heat loss, is to look at, to do some survey. This is a thermal image, and the thermal image is going to show you where are you losing basically heat. So the red ones here, they are showing that, okay, you're losing heat. And the kind of like a cooler colors, like blue, that means that they are okay. And this is something that sometimes you can kind of like understand on snowy days, like the day after, if you see that, okay, there's no snow on the roof, that means that, oh, that's it. So this building is not performing very well because, all the snows are gone. So kind of like the reverse image here. So as you can see around the windows, edges, kind of like we said that one, see that all of them are red. That means that you're losing your precious heat through the windows, openings, doors, and stuff. So I just want you to notice here, there is a little red here, and there is nothing here. So we have all the windows. So what is happening? It was a wall, it's a solid wall all the way. You see, all the solid walls are yellow. All of a sudden, there is a red one here. So there's something happening. These are the invisible things that normally by looking at them, you cannot understand that. So this is, I can only imagine that. I've never been into this building. I can only imagine that probably there is a radiator here because, below that window, and there's something wrong with the structure of that wall. And all the heat from that radiator is passing through the wall. That's something that you can understand when you do the proper monitoring. So what we have to understand is that a measure here that we have called U value, and if you're going through refurbishment and if you're doing substantial refurbishment, that you have to comply with the building regulations. If you're replacing, so all of them are kind of like available in building regs, and you can talk to the commissioner officer in terms of what you have to achieve. But this is the capacity of a material, basically that value is to resist against heat. Some materials are good, heat resistance. You know that. So one of them, if you are ironing, you completely understand that, how this is going to work. So if you have metals, you put an iron on a piece of kind of like metal, it's going to spread the heat quickly. But if you put it on a piece of cloth, it takes more time. So the same thing. So if you have a building, fully with metal and iron, so the moment there's the sunshine, so 1 minute later, the building starts heating up. So we're looking at the material and the capacity of the materials. Some people are asking, okay, how much insulation do I need? It's not about the thickness of the insulation. It's also about the property of that material that you have. You have to understand that the property and thickness are working together. So different materials, they have different U values, and that is going to determine how the building is going to keep the heat basically inside. So when we are looking at this heat loss, so we have introduced some very good insulation. We have put air tightness, we have put the membrane and everything, but still we are losing energy, and that's coming back to the thermal bridge. Okay? Again, think about the submarine. Okay? That's a good analogy. So when you have two materials with different kind of like thermal resistance, with different heat resistance, different U value, hitting each other, they are in close contact. Okay? Imagine that if I have, this is like a piece of metal and cloth. Okay? So if I warm that structure, so that piece of metal is going to pass all the heat. It doesn't really matter. The cloth is not going to work because it's going to heat up and it's going to quickly pass the heat. Okay? This is the same happening here. Okay? So you have the insulation, okay? But this kind of like a joist is going through the wall. Okay? When this one is going to heat up, it's going to pass all the heat through the wall. Because it doesn't matter if you have insulation here. The property of this one, that means that it allows heat to go faster. Okay? And it's always going to find the easy way. Heat is always going to find the easy way. I'm going to say that, okay, I'm going to heat up this room. So insulation here, it's okay. What is the best option? This one, the floor, I'm going to find my way through the floor. Choose. This is how it works. So it's a wicked kind of like a system. So you have to, the way is to actually make sure that, again, submarine, to go around this one. Okay? So to go around it. Sometimes in refurbishment, it's not an easy task to achieve. I completely understand. Just want to say that, okay, sometimes you have to remove something, put something on from the, at the end of it to wrap that joist to make sure that it's not going to find its way. Okay? If I have this insulation all around it, so heat is coming, and it's going to say, there is no way. All of them are insulated. There is no way for me to escape. So I can decide to stay here inside and keep you warm rather than trying to actually keep the outside warm. Okay, so let's quickly have a look at roof and loft to see what we can do. So we have two types of roofs, cold roof and hot roof. The cold roof is that when you're not actually living in that area, so it's not a habitable area. So what we are looking is that to make sure that we have insulation at ceiling level. Okay? So insulation has to be at ceiling level. Then we let the ventilation inside that area. Because what we don't want is the moisture to be trapped here. Because this is hot. If you heat it up, water is coming up, and that is going to basically be your shower window. It's going to release all the water in the loft, and that's sometimes we're going to see that you have black mold in the loft. You're not living there, you don't know what's happening. After a couple of months, you're going to see what's happening, black mold. This is invisible, so you have to kind of look at that one. So that's versus the warm occupied roof. So warm occupied roof, so you have to kind of put the insulation at the rafter level. So in that one, so we make sure that, as you can see, when we heat this area, also we're going to heat that area as well. So different types of kind of a roof, if you were going to consider that. Let's have a look at windows and doors. So especially windows, you're losing heat, both from the conduction. That means that through this piece of glaze, which is it's not the best kind of or effective material in terms of kind of insulation, also around the edges. And in old buildings, we have a lot of issues with this kind of air tightness and kind of problem with windows, and we are losing heat. Especially, I think that sash windows are kind of problematic because they have so many points of contacts, and they can go wrong if you don't consider that. So one of the example, again using a thermal imaging, this is a normal one without kind of old sash window before any kind of insulation. And the second option, as you can see here, they introduce a secondary glazing. That means that another piece of glazing that you're going to put, just with a couple of kind of centimeters behind your window. So that means that it's not a double glazing. They haven't changed the original kind of window, which is something that you may want to consider, because some people, when there's some studies showing that people, they like to actually see the original features, and it's going to add value in terms of selling and renting. So there are some other options before jumping to, PVC kind of plastic base kind of a double glazing. So shutters are good. So do not kind of ignore them. If you have a proper kind of shutters that is going to be closed completely with the brushes at the end, it's going to actually be very, very effective. Secondary kind of glazing, especially if you're kind of in an area that kind of and you kind of a listed building, that would be an option. So curtains also very good, but make sure that they are covering the whole thing and there's no gap, between them. Again, when you're putting curtains, think about the submarine. It has to go. The best one would be floor to ceiling. If you have a gap, again, the heat is going to find its way. Okay, so remember that if you have a curtain and you finish it here, so the heat is going to find its way. So you have to make sure that it's floor to ceiling. So old windows, they can improve. So mean that if you have a good kind of a local craft person, they can actually look at the old windows and improve them by adding the draft proofing members to the window. So it is possible to actually improve them. And some of these windows, especially old buildings, some of them are slow-grown timber, and they're always a very, very good kind of material, and they're gonna stay, for a long time. Another thing, when you are thinking about, insulation, again, everything you have to consider that. So all these little things, such as this kind of fixing, this one is not going to introduce any thermal bridge. Okay, simple as that. So if you use a normal kind of nail, it's going to crack that wall. You're going to allow the heat to pass through it. We're talking about the nail. So this one is a thermally broken one, and it's not going to allow anything to pass through it. If I have wall like this, put a nail on it, that nail is going to induce a point of kind of like a weakness for this wall. Okay, so very quickly we are going to look at, that's on Wim. So very quickly we're going to look at some of the materials that you can kind of use. They're coming in different shapes, so bats, slabs, boards, rolls, loose fill, or spray foam. So you have to understand which kind of like a material works better for kind of like the installation that you're going to use. So for old buildings, we recommend going with kind of like a natural material. There's a lot of natural, good, insulation materials, cellulose, cork, hemp that you can actually use. Okay? So avoiding synthesis material because these buildings have not been developed for those types of material. If it was a new build and you design it at the beginning, with this specific material, yes, but introducing a material that is not natural to an old building might actually be problematic. On the other hand, we are looking also at the embodied energy inside this material. These are kind of like a naturally sourced material that kind of like very good for the environment. So here you're going to see that, for instance, the wood fiber bats to be kind of like insulated. These are the stuff that you can kind of like cut them and put them. So remember that by cutting them and putting them submarine. So the gap should be filled. No gap, no crack. Stuff that you're seeing that maybe like a 1 or 2 millimeter gap is going to create issues. So you cannot just leave it like this. You need the air tightness membrane as well. So do not push them. So these materials, sometimes because they're not hard and they're coming from natural kind of sources, you kind of like push them so you can push them in to shove it into place. So they're losing their properties. So they are working at a certain kind of condition. So if you push them, so that means that the air trapped inside it is not going to kind of like be at this kind of level that has been designed. So these materials also can be a good kind of like insulation in terms of fire. So we can look at that one as well. So while you're kind of looking at thermal properties, look at the fire resistance of these materials, because also all buildings, they are kind of like, they need to be fire resistant. So hemp chip, one of the materials that I like, that it's very easy. It's chopped up with the core of the hemp mixed with lime. So this is a sort of material that you can introduce because it's going to be a very good material in terms of insulation and also in terms of breathability for old buildings. So this is how you have to start thinking about what kind of materials I can use for my building. So all of them, these stuff that we mentioned about heat, we talked about breathability, the amount of water, humidity is going to have an impact on indoor air quality, and that's the air that you breathe every day. So also the materials, the naturally sourced materials, can help us in terms of improving the air quality. And you spend 80% of your life indoors. So it's very important to consider also the air quality. One of the other things that you need to consider in terms of air quality would be the volatile organic compounds. These are the VOCs are emitted as gases from certain materials. So mostly chemicals. So if you have dry cleaning clothes, if you have DIY material, some paintings around, some furniture, some materials that you bought that they use for furniture, they are not very good glue, or even kind of like a nail varnish, they can actually release these gases. So think about the air quality of your home as well. So it's not just about heat, also it's about air quality because it's going to have an impact. So have a survey before you start doing anything. It is very important to run a survey. do a little bit of monitoring. These monitoring devices are coming to the market. They are very affordable. So maybe you can purchase one or two and put them maybe in your building, house, or in the loft just to see what's happening. So what is the level of humidity in your loft? And is it going to be a high level of humidity, or it's at the level that it's acceptable? So before you start, you can get some data to use that data for any decision making. Have a look at the kind of like a new specification that we have. This is sustainable retrofitting, and you start looking at the whole house approach. You have a risk-based assessment. You need to have retrofit coordinator and competency requirements for retrofitting. So let's finish with this image. So this is a timber frame house, 1920. So, and this is the old photograph of this building. And 1970s, they have introduced some new measures. So one of them is that they removed the line render, and the infant panels were covered in a cement-based finish. Remember that cement is not going to really a breathable material. So this is before installation. As you can see at the top, as you can see, this is how the building is going to work. Look at all those windows, even walls. They're, losing kind of like energy. Look at all these corners. But after the installation, they have brought back, they have removed the cement-based render. They have introduced lime-based render, which is more breathable, and also it's a good material in terms of air tightness. Added secondary glazing, air tightness, and that would be the final kind of like version. And as you can see, it has a better performance. Okay, and that's it. Let's just have a break.
Right, okay, so moving forward, I'm going to be looking at heating and cooling. This is going to include renewables as well as what we've got as current systems. So, first thing with heat and cold is identifying your demand. And that very much depends on, one, your building, and two, your habits or your family's habits or your inhabitants' habits. Right. So when it comes to hot water, are you using the dishwasher? Are you washing up with lots of warm liquids? Are you showering every 4 hours or every 4 weeks? Are you taking a bath every day or every week? These are your hot water demands, because, effectively the more hot water you require, the more you will have to produce. Heating and cooling I've thrown together because they're kind of, two sides of the same coin. Most people tend to be concerned about heating, especially in the winter. One of the challenges you've got is as soon as you start to better insulate your property, you're not only longer thinking about heating, you probably want to start thinking about cooling at some point as well. Right. To give you one reference here, if we're looking back to passive house will look and consider cooling or the maximum temperature within your property. And that is normally taken at 25 degrees. And you shouldn't, or at least most of the calculations aim to not go above 25 degrees for 5% of the year. That's obviously taken into account where the property is located, etc., etc. Right? So that's just giving you a bit of an indication. I'm pretty sure that most of you will have, over the last heat wave, around the last weekend, have noticed that your properties, if you're living in a recent one, has gone up significantly. And it becomes then quite often very hard to bring that temperature back down. Yeah? And what you then wonder is, why do I spend so much energy heating it up in the winter and I can't get rid of the heat in the summer, right? So one of the questions really is, where do these demands lie? Are they hot water demands? Are they heating demands? Hot water demands tends to require high temperatures. heating demands depends on the heating system, and I will come to that. Depends on how much of the house you're heating, to what temperature you're heating it, and so on and so forth. Cooling demands, does it need cooling, when, how regularly? And we'll talk about that in more detail. So boilers, we've got the old style systems on here, oil, gas and hydrogen. Hydrogen is probably what we are looking at in the future. The reason I've got all three of them in here is oil boilers are no longer going to be available from 2025 onwards. So for people who are kind of off the gas grid, that's something to take into account. When it comes to hydrogen, it is massively talked about. What is currently out there as in the plan, so to speak, is that we are looking at a 20% blend of hydrogen with the standard gas network from 2028 onwards. And then in the 2040s, we may be moving to 100 hydrogen. Big challenge with hydrogen is there is barely any natural hydrogen. So hydrogen production becomes a big question, right? So that's one of the challenges with moving over. Gas versus hydrogen. Hydrogen has a much higher energy density. I've got the three standard systems here at the bottom. Left-hand side, combi boiler. I would say that's probably the plumber's favourite these days. We've then got system boilers and heat-only boilers. Combi boilers will switch on demand. You require hot water, you require heating, they switch on. The reason why plumbers like them is because they say, well, there's less gas production or gas requirements, and we don't need to think about a loft tank. So again, it saves space, and it is less tubing, and so on and so forth. The reason why I've got these two systems here still on here is if you are thinking renewable energy, if you are thinking solar thermal, you will need a storage tank somewhere to keep your hot water in. Even if you're thinking about solar voltaic, so producing electricity, you will maybe thinking about using your immersion heater in that tank to heat up that tank. Right? So that's why you may want to consider still having that tank somewhere in your property. Difference between these two system boilers are pretty much a package all in one. They normally have expansion vessels in there, they've got the valves in there, and so on and so forth, which is slightly different from most of the systems that you find, which is what they call open systems or vented systems, and that's the system where you normally find a loft tank. The reason why I've got them on here is that loft tank is one of your heat leakages within the property. So you need to carefully insulate that. Yeah, otherwise you're losing heat over there. You can bring this to a closed system, meaning getting rid of that loft tank. One of the things to take into account is that you then work with an expansion vessel and you have to think about the pressure that's going to be on your system. If your system is really old and has never been under very high pressure, if you start to pressurize it, you might find that you've got a few leaks around the property, yeah? Which may or may not be easy to overcome. Right? Most boilers these days are condensing boilers. It basically means that they are using the heat that is in the gas to also warm up your water. Right? So effectively you've got the cool water that returns from your radiators, passing by what is effectively the exhaust gases, which tends to be one of your higher temperatures, before it then goes across what is the burner side and flows out again. Right? The reason they're called condenser boilers is because if you do that here, going back to what Mohammed said, you're going to have condensation, and therefore you need to have a drip feed to basically take away the condensate. Think about where your condensate goes. Your plumber likes to just go straight to the wall. That's the easy bit. There's two problems with that. First of all, it may freeze over the winter, which means your boiler stops working. The second one is you're creating an incredibly nice thermal bridge between inside and outside, and if it isn't sealed properly, you've got an air leak on top of it as well. Right? So try and plumb it back to existing pipework wherever you can. Talking about boilers, one of the recommendations is to think about the flow temperature, meaning what temperature does that boiler heat your water to, right? So that should preferably be as low as possible. Now, this is something that personally I play with within my house, and I recommend you have a check as well. You can pretty much adjust that fairly easily. Either you have a turning knob, or if it's a digital one, you can basically push it up and down, right? In your spring and autumn season, you probably don't need it as high as if it's, freezing -2 in the winter and it's a really windy day. Yeah, because if it's freezing in winter and it's a really windy day, your property is going to cool down incredibly quickly, right? If your flow temperature then is really low, you're going to struggle to warm up your property. Yeah, but in what I call the transfer season, spring and autumn, what you probably want is you want to get rid of the chilly feeling. You don't want that to be very high then, because what happens then is your system switches on, you are all happy and comfortable, it switches off and you go, this is cold here. And the first thing you do is you run to the thermostat and higher it. Right? So there's two ways to work with that. First of all is bring down that flow temperature. And the second one is what I will talk about in a second, which is the circulation speed on your system. So what you need to think about here, flow temperature. If you have a standard radiator system, most of these will be set to the max by plumbers, because it means they don't get the cold because, the property doesn't heat up. My recommendation is bring it down as much as you can, because it reduces your gas consumption. Right? When it comes to hot water, you like it to be around 60, 70 degrees at least once a week. Otherwise, if you have a storage tank, you'll have to consider the possible growth of salmonella in there. And that's not good, right? Normally, your hot water is not drinking water, so it's not that concerning from that perspective. If you drink underneath the shower, you may want to think about it, right? But most people don't. Maybe you sing and then you swallow, but that's a different story. Circulation speed. Every system will have a circulation pump pumping that hot water around the property. Most of these pumps have 3 speeds. And the easy setting for the plumber is the maximum speed, because then they don't get any complaints. Right? You can bring that down quite often. Again, when it comes to spring and autumn, I bring that down probably to speed 1, to be honest. The benefit of changing that speed is I basically lower the flow rate of my hot water circulating through the property. So that means if there is a lower flow rate through this radiator, it will release its heat more slowly over time. Now, what I want in spring and autumn is I want to feel comfortable. I don't want my heating to be switching on and off all the time, because then when it switches off, it drops too low and I feel chilly. I'd rather have my heating going incredibly slow in warming up, and I feel warm because I always get that warm feeling coming from my radiator. Right? There is a bit of a rule you can play, and this will be explained in more detail in the material that we're sending afterwards. I personally go through it based on the flow and what I feel in my property. Is it the right speed, or does it really, do I feel like running to the thermostat? I probably think about switching up my pump speed first before I run to the thermostat, right? Or if I then notice that I've, increased my pump speed, I may have to think about increasing my flow temperature, right? So there's some things to play with around your property. So when it comes to heat and cold generation, some properties have electrical heaters out there. Those may be electrical storage heaters. The one thing to think about with most of these first 2 systems, so the infrared and the electrical storage heaters, is you get a one-on-one reflection of heat. So 1 kilowatt in, 1 kilowatt out, pretty much. Now, personally, I'm not a big fan of electrical heat, because if you think about the efficiency all the way at, your generation power station, and then you look at how efficient it still is when it comes to your property, you've actually had quite a bit of losses. You may think in your property it's 101. When it comes from the power station, you've already lost at least 30%, which isn't great. Obviously, you don't always have a choice on that because some properties just come with whatever the system is there. I mentioned infrared heat because it's a radiant heat. Radiant heat means it makes you feel comfortable about this being warm more quickly. And that's why some people like it, right? Heat pumps, probably the topic of the day when it comes to buildings. Heat pumps are not new. Let's start there. Most people say this is a new technology. No, it's been around for 150 years. It has been used in many countries. You know, when you go to Asian countries, etc., it's been around for a long time. If you are as generically, you know, because heat pumps is a very generic term, air conditioners are actually heat pumps as well. Right? So, and we've all been familiar with air conditioners for quite a while. They work on the same principle as a refrigerator, which everyone knows. Now, a refrigerator is effectively what I call a heat displacer. So it takes heat from one space and brings it to another space, right? And that's how your heat pump works. But then you have to consider your property as that one space and your outside or your ground, if you're looking at a ground source heat pump, as that other space. Right? So one thing to take into account with heat pumps is their flow temperature is much lower than a standard boiler. Your flow temperature efficiently out of a heat pump is about 40-50 degrees. Now that automatically means that if you are a consumer of a lot of hot water and you want that hot water to be 60 degrees, but your property doesn't really need much heating, then probably a heat pump isn't your best solution. Right? Something that salespeople won't tell you. With heat pumps, they always talk about something called the coefficient of performance, which is how much efficiency you get heat out versus the amount of energy you put in. So that means I put 1 kilowatt electrical in, I may get about 3, 4, maybe more electrical kilowatts or heat kilowatts out of that system. Right? And that's why, in that sense, from an electrical perspective, they're better than the first two options. Refrigerants, I mentioned them here. There's a bit of a move there towards, I think we're currently around isobutane, we're moving towards propane, ammonia, and carbon dioxide. For those who've lived long enough, you understand why we're changing refrigerants, because there was quite a bit of change on that in the fridge scene, let's say in the 80s and 90s. Yeah? And that's continuously ongoing. Their expected lifetime is also much longer than a boiler, which is one of the positives. Air source versus ground source. Air source is cheaper, as you can see, versus ground source. Obviously, you need an outside unit for your air source, and you need a good space around that unit, normally about a meter either side. Why? It needs air. It needs changing air, so it can extract the heat from that. If it's in an area with stale air, obviously you can't keep extracting heat from the same air, right? So it's quite easy to install. You preferably don't want to put it in the sun, because then it's going to struggle to get cool air for the summer. And you don't really want it in too strong wind either. These units are not that noisy. So at about a meter distance, they're about 40 to 60 dB. 60 dB is a standard conversation, human to human. Yeah, so that's not very noisy as such. Something else I was going to say, and I've forgotten on that one now. Ground source heat pump. So coefficient of performance, is about 2 to 4. So that means 2 kilowatts or 4 kilowatts out for 1 kilowatt in. Now that efficiency drops as my temperature drops, unfortunately. The other thing I was going to say with these is, and that's generically with heat pumps are currently promoted massively, and in some cases you can get some government funding for that. But that is for the heating side of the story. And that also means that those units, when they are installed, can currently not be used for cooling. Talk to the politicians about that one, not me. These systems can cool. Remember heat displacement? I can take the heat from the outside or I can take it from the property. It doesn't make a difference. Why would I go for ground source heat pump? Higher coefficient of performance. One of the big benefits of ground is it's at about stable 6-7 degrees, roughly. So I have a pretty constant temperature in my other medium, so to speak, which I don't have with air. Yeah. Installation is you've got a more cumbersome issue here because you either have to put pipe work around your garden, and then you need a fairly big garden because it needs to be about 2.5 to 3 times the property's floor area, which doesn't work for most gardens in the UK, or you go down and drill deep boreholes, which ends up being quite expensive. And the other challenge in that context is you can kind of wish that your neighbours don't start doing it as well, because then your efficiency goes down. Right? That's a long-term consequence of it. Benefit is unit goes indoors, slightly more silent as well, and obviously links with a heat store. So some things to think about with regards to heating is, what are your flow temperatures? If they're low, you're thinking about things like floor heating, wall heating, which I'll come to, or you're talking about enforced units, which we all know from the air conditioning units. These are effectively simply, a radiator or some pipe work with fans over it to enforce my flow. Yeah? If I'm at much higher temperatures, 60 degrees and above, I will have that natural effect of getting the heat through my room. Yeah? Now, you may say, well, you recommend us to bring down the flow temperature and I've got radiators. Can I bring it down to 40, 45? Yeah, try it. See what happens. Yeah. It's probably not going to work in the winter, but it may work in spring and autumn. Yeah. Floor and wall heating. I mention wall heating because it's something that very few people are aware of. And it is actually, from a human perception perspective, much more comfortable to us humans than floor heating. Yeah. The problem with these systems is they obviously have a slower response. They tend, you switch them on for winter and you leave them on for winter. You're not going to switch them on because, you're going out for half an hour, coming in, etc. No, that's not what you do with floor and wall heating. You are kind of heating up a mass, either your floor or your wall, and that then starts to radiate that heat out. Can I cool with these systems? Yes, you can. You can cool with both of these. Yeah. You can actually cool with these as well. You will never be able to cool with that, or you will need very interesting drip trays and fans and whatever else you may fancy. Right? Not going to work. Needs lower flow temperatures as well. You are going to run that system around 40, 45 degrees. So, which is one of the reasons it's being sold with heat source, air source heat pumps, ground source heat pump, because I need that lower flow temperature. Right? Here at the bottom, very quickly, to make people understand a bit more about how that heat transfers. So, heat transfer depends on the temperature difference. My heat source versus the space or whatever I want to transfer the heat to. So that could be my radiator being at 60 degrees, my room being at 20 degrees, or 10 degrees if it's winter. The area, so the side of that radiator. So rather than putting one huge chunk radiator in this room, I've decided to put about 7 or 8 in here to get to that required area. And then the transfer coefficient depends on whether I have a standard, metal sheet radiator, as in this room, or I have these enforced radiators that have fans blowing over it, and therefore will be more efficient. Yeah? And that determines how efficient my system is going to be in transferring that heat. Moving over to mechanical ventilation. Why is that here? Because, my colleague says, make your property airtight. But you're living in there, and you obviously still need air to breathe, right? So one of the moves there is, I would say, nearly moving away from what they call the trickle vents. And there's a bit of a trickle vent plague in this country, because if you think about proper trickle vent, it is the perfect air leak source. right? I go from indoor to outdoor with barely anything in between. And in most cases, the trickle vents are poor quality, so you can't even close them properly, right? So if I then think about, my letterbox, that's nothing compared about, in comparison with all the trickle vents that most people have in their room. Yeah? They're your air leaks. They're your heat leaks as well. So once I start to tighten that up from an air leak perspective in my property, I have to think about getting air in there, oxygen effectively. So mechanical ventilation with heat recovery is one of the ways to do that. This tends to bring fresh air from the outside via heat exchanger, which I'll talk to in a second, into the living spaces. Your living rooms, your bedrooms, so the spaces where you spend most of your time. It will extract what they call the stale air, what I tend to call the dirty air, from your bathrooms and your toilets. Yeah. What it does is it takes the heat from your stale air and it puts that into the air that's coming from the outside, that you're sucking in from the outside. Most systems do this with an efficiency of 80% plus. Some of them go up to about 95%. So that means that the heat that you've put into that room is actually going to stay into your property. Yeah. The other thing to think about is that these systems also tend to come with filters, and therefore you actually filter the air that comes from the outside. So for people with allergens, normally that's a very good point as well. So very much aimed at airtight properties, I should say. Don't think about this if your property isn't airtight. Why? You're basically going to suck air out of a room, and rather than that air coming from your living room, it's basically coming through your trickle vent from the outside. Yeah. So what you want is an airtight property so that the flow of the air that you're bringing in is actually also the air that you're sucking out of that property, and you don't extract that or produce that with an air exchange anywhere else in that property. Creates a more controlled environment, and so on and so forth. And it can be extended with heat exchangers and coolers. Yeah? So you effectively can have additional benefits there as well. So in very modern new builds, they now start to combine these mechanical ventilation heat recovery units with heat pumps. And then you can start to nearly extract the heat that's coming out of that property, and you can put, if you want, that heat into your mortar, because we produce heat, right? And so if you have a really nice, property that's very good from an airtight perspective and doesn't leak a lot of heat, it means that you are going to be putting a lot of heat into that property, and you may want to extract that. And if you can then use it to have a hot shower in the evening, why not? Right? Renewables. Solar thermal, 2 systems, concentrated solar, only really at industrial scale, vacuum tubes or flat panels. As said earlier, they need to go with a storage tank, and that storage tank obviously needs more than one coil. So one coil could be from your boiler, the other coil could be from your solar system. You need to think about the tank size, i.e. how regularly do you shower? If that's a lot, you may want a bigger tank, right? And from a demand perspective, you need to think about, 1 square meter of panels per person living in that property. That's a rough rule. Flat panels and vacuums, what are the differences? The vacuums are vacuum tubes. So this is a glass tube, this is a vacuum, and then you've got a liquid, which tends to be not water because it can go to much higher temperature. And so what you have is you have the heat absorbed. The heat obviously means that the hot liquid goes to the top, and then it gets exchanged at the top and goes into your tank. Benefits of vacuum tubes is you can install them on your own. You basically can have, fit the size of tubes that you need for your property. It has a higher efficiency in colder and cloudier conditions based on the vacuum. The disadvantage is if it snows, it won't defrost itself, right? Because of the vacuum insulation as such. But it can produce a much higher temperature output, again, due to that vacuum. And you can rotate these tubes. Some of them have reflectors in them, and then you can rotate the reflector to where you will have most of the sun coming from. If any of the tubes fail, you can replace them. Flat panels, they tend to be cheaper. They are not that efficient. They will lose heat over the winter, which also means that they will defrost your snow during a snowy period because, you know, that leakage. And you will need more people to get them up there. Photovoltaic, 4 main types currently: monocrystalline, polycrystalline, passive emitters, and real cells and tin films. They're largely different from a perspective of how efficient they are. And with the higher efficiency comes a higher cost. No surprise there. How do you recognize them? The monocrystallines are the pure black ones. The blue-purple ones that you can see on the right-hand side are polycrystalline. Poly, multiple colors, therefore, you know, easy to remember. And you have to think about, you know, most panels are about 1 to 2 meters, depending on which brand, which type you buy. They may be a bit wider, a bit longer, or a bit thicker. And they will go from about 250 to about 400 watts per panel. The one thing that most salespeople don't tell you is that the efficiency they sell you is at 25 degrees for that panel. Now, in a sunny day, it wasn't quite the day, these panels will easily go up to 60 degrees and higher. And you can see here on the right-hand side on this graph what that means for the efficiency of these 4 different types of panels. That drops quite a bit. This is why, if you have solar panels, you should absolutely love a winter's day with a lot of sun, because my temperature is lower, I'm on this side, and therefore my efficiency is extremely high. Last but not least to mention, photovoltaic thermal. Effectively, you've got heat and electrical output. Challenge here is I'm trying to extract heat, but I don't really want to heat up my panels because then I lose efficiency. So, you know, it's a bit of a mixed feeling on those one, really. Storage, why storage? What we've got here on the right is a bit of a, you know, idealized generation. So I get sun coming up, get sun coming down. It never looks like that. It looks like that, obviously. But it shows that what I produce is effectively what's underneath that orange curve. What I consume is effectively what is underneath that blue curve. So I'm doing fine here, but I have a problem with these areas. And then the question is, do I want battery storage? Do I want to put this into a solar, you know, hot water tank? Or what do I want to do with that energy? Or where am I going to get it from? So it's trying to match generation and demand. 2 different main types of batteries, lead acid, which is what effectively is in your car as well. But the ones you buy for solar systems tend to be slightly different because they allow a higher depth of discharge. Depth of discharge means I've got X capacity on my battery, I can bring it down to, in this case, 50%. Right? So I can never go lower than that 50%, or I can scrap that battery. Right? Lead acids, lifespan of battery to 5 years. If they're sealed, 5 to 7 if they're flooded. Efficiency about 80 to 85%. They are the cheapest, and they are also the best when it comes to going fully off-grid. The other option tends to be the more expensive one, which is lithium, which everyone knows from the phone batteries, but then obviously they're much bigger in this case. Lifespan about 10 to 15 years for the good ones, which also tends to mean the expensive ones. Faster charging, higher efficiency, 95%. Depth of discharge, 80%. So I can drop that to 20% of its original value, which means I can get much more out of that battery overall. Right? They're more expensive and they have a higher density as well. So when it comes to locating these batteries, there's 2 different approaches. One of them is effectively, if you are installing your system now, as in solar panels plus batteries, I would recommend you go for the system on the left-hand side, solar panels, batteries. I've got one converter which takes my DC into the AC that goes around the rest of the property. if you install your battery later, you tend to happen to be on the other side, which means solar panel, conversion to AC, battery here, so conversion back to DC, etc., etc. Right? The problem here is you've got two inverters, and obviously each time you invert between the two, you have a loss. Right? This is from a systems perspective within your house, and controlling it also much easier because it appears as one system. That's just providing energy to you, whether there's sun or there's no sun. So, building automation. Starting off with thermostats. Most people have a thermostat like that in their house, which tends to be a bimetal, which basically flicks on or off. That also means that you are doing this. So my set temperature, I go over, it switches off, go under, and so on and so forth. The problem is down here, you basically say, well, I've set this to 18, but it's only 17 or 16. I feel cold. And so what you happen to do is you push that up. Right? That's what people do. They go to the thermostat, turn it up. Right? Now, what other thermostats, which are now called smart thermostats, don't ask me why they're smart, they're not that clever, is they try to achieve or get close to that set temperature. And they try to stay there. Which they do by switching on and off more quickly, or in some cases they will effectively look at a 10-minute period and see how much of that 10 period your system needs to be on and how much it needs to be off. So all you're doing with these systems is effectively trying to, avoid that chilly period. Yeah. Remember, I told you how to deal with that chilly period by switching your flow temperatures and your flow and your circulation speed. You can actually influence that curve as well. Right, a bit more on smart homes, because that's obviously an upcoming trend. One of the questions is, what do you want to automate? Some people say, I just want heating and cooling, which is what most people already have anyway, right? But then the question comes, I'm putting blinds in. Okay, do you want to automate them? My lighting, I really like, a movie atmosphere at night, with a bit of coloured LEDs and things like that. Okay, you might want to think about it. Audio video. If you're a cinema fan, you want to turn your living room into that cinema feeling for your Saturday nights. Again, something to think about. What are the real benefits? You have increased automation. At the end of the day, they call it smart home. It's not that smart. It's effectively automation, right? But it's expanded across a range of different areas as you like, right? Improved comfort of living, rather than sitting down and, getting that right dimming level on your lights, you basically just press one button and it happens for you, right? You can do at home simulation. Effectively, you go out on holiday, you go out for dinner, you don't want your neighbours to know. Effectively, you will have lights switching on and off, and it appears like you're going to bed as normal, but you're not even at home, right? Tends to mean lower energy consumption, and you can do remote controlling and checking. So you're away, you might have cameras around the property, you might want to check out what's happening. You might want to, change your lighting condition because, it's a movie night, therefore your lighting pattern of going to bed at 10 needs to move to 11, and so on and so forth. We've got a lot of stuff out there. We call them IoT, Internet of Things devices. I've dropped one at the top right. I think that's an Amazon Alexa in one shape or the other. They come in many shapes and forms. They often come quite cheaply. They cost you around 100 quid or a bit more, which tends to mean people chuck out and, buy one and just try it out because it's that cheap. And then they see what they can do with them. Now, a few things to think about. How much data are these companies gathering? These things are constantly connected to the web because it does voice recognition and it does it in the cloud. It doesn't do it within your property. So whatever you say goes into the cloud, gets decoded and gets sent back to your property. Now, is this thing only listening when you say Alexa or not? You decide. Question 2 is, how long are you going to get support for? These are coming to the market at a fairly cheap price, because they want to, get people to buy it. The reason why Amazon brings out Alexa is because they want to put you, get you to put your orders through that system. Makes their life easy and, lots of more profit. But are these things still going to be around in 5 years' time, 10 years' time? What happens if these companies go bust? And will you then need to buy another one? Or will you need to buy another one because it's no longer going to have a software upgrade? Right. Technology moves fast, so think about that. Cheap and cheerful versus equipment that comes with the building. One of the points I want to make here very much is there are some big players out there which then kind of wire the system in there, Lutron, Creston, Control 4, etc. There's a lot of them out there. Most of them are single companies. That effectively, if they go bust, that's it. Your system, what does that mean to your system? You've wired your whole house up with it, and then, right? The reason I bring all of this up is because there is effectively only one worldwide standard around smart home, and it's called KNX. It is supported by over 400 manufacturers. One manufacturer goes bust, I'm not lying awake at night. It costs a bit more, but it keeps the whole system within your property. It isn't linked to the internet unless you really want it. And effectively, from those perspectives, brings you with a very different system. So, some things to think about: upfront cost versus long-term cost. What do you want to invest now? How long do you want that investment to last? And are there going to be any monthly subscriptions? Anyone who's got a Ring doorbell will remember that over the last year, they've probably upped their monthly subscriptions by about 40%. You either went in and paid for that, or you could throw your Ring doorbell in the bin. Your choice. Right? Will your system continue to work if the internet goes down? Won't work with an Amazon Alexa, etc. What happens if the electricity drops away, even for a fraction of a few seconds, and comes back on? Is that system still going to work? If you're on the other side of the world and you want to log on to it, is it going to come up correctly so you can still log on? Or are you going to lie awake because you can't keep track of what's happening in your property? Technology obviously moves pretty fast, but also think about what carbon impact these cheap systems may have. You're throwing them away. Again, there's a life cycle element to that. Security and privacy. Use, convenience, and security privacy are often contradictory aspects. Amazon wants to make your life easy. But what does that mean to your security and privacy? What data is retained by whom, where, and for how long? Who reads the small print before they click, yes, I agree? Very few people do. And then they keep changing it anyway. And either you agree or you throw it in the bin, right? Keep in mind, usage patterns can reveal things like presence, type of activity, etc. Anyone who's got a smart meter, I can pretty much tell you which device is switched on when. I know when you're at home, I know when you're putting a washing machine on, I can tell you when your dishwasher is on, etc., etc. Smart meters aren't designed for customers, they're designed for the energy supplier, unfortunately. So, quick wins. Turn your thermostat down. Any 1% saving, you have about 1% saving on your bills for every degree per 8 hours. Check your timing settings, adjust it based on the season. Turn back at least 7 to 10 degrees between what I would call your day cycle and your night cycle. Yeah. So let that, don't let that run continuously. And don't heat rooms you don't use. People feel like they need to, heat up their whole property. Why? I don't understand. I really don't. Turn your boiler down or off. In the summer, my boiler is only switched on a few times in the week to get hot water, and that's it in the summer. Otherwise, why run it? Consider your hot water temperature, based again on the season, and insulate. The reason I've got pipe insulation on the top right corner is, any pipe work that leaves your boiler in before it gets to the radiator, if it loses heat there, and that's not part of your room, that's lost heat. If your pipes obviously run through the room like here, then don't bother, because that's coming into your room anyway, right? Those insulators, very easy and cheap to install. Obviously buy the right sizes, and the thicker you can buy them, as in you can see you've got different thicknesses for the same diameter of pipe, the better. But make sure that you can fit them, because sometimes you might not have enough space between your wall and the pipe. The other thing to think about is this works very nicely for straight pieces of pipe. Once you get to a single corner, that's all right. Once you get to a tap or a valve or something like that, you kind of go, what do I do now, right? So what the DIY shops sell you is this, and then you can start wrapping it around. That's basically aluminium foil with bubble wrap in the middle. What I recommend you to buy is this, which is about a meter thick, wide, sorry. It costs the same price as all of that. And if you spend about 5-10 minutes with a scissor, you will have many of those wraps for the whole of your property. If you have a loft tank insulated properly, as you can see over here, and I would say insulate as much as you can, taking into account things around condensation point, dew points within the wall, and so on and so forth. Think about drafts, cold spots, draft exclusion, keep windows closed, ventilate at least 5 minutes a day. Install curtains, but if you install curtains, think about how you install them. This isn't going to help, because the heat is effectively going behind the curtain, and this is even worse, right? What I want my curtains to do is effectively create a sealed box between the window and my room. Any sealed off space with air is going to be an insulator. Anything that gets in there from an airflow perspective is going to mean a loss of heat, right? When it comes to the property itself, you can think about things like expanding foam, use it correctly, and think about draft excluders. Those brushes here that you can see either on a two-sided strip or on a metal strip are extremely useful around doors and so on and so forth. Yeah. For those who have a chimney, you might want to think about what they call a chimella, which is effectively an umbrella to go into your chimney to block the heat from escaping there. Yeah. So reduce your hot water use, 4-minute showers, reduces your water consumption and your energy. Reuse wasted and capture rainwater where possible. Use it for your garden at least. For those who install a proper rainwater tank somewhere in their property, you may want to think about using it for flushing toilets and even your washing machine. Lighting, change over to LED. It's very easy to see how much you're saving by doing that. If you've got standard 240 light bulbs in your fittings, then it's an easy replacement. If they are tend to be 12 volt LEDs in your fittings, you can ask your electrician to effectively change the transformer to another one and keep your fitting if that's your favorite fitting. That's what I've done around my property. Do those lights need to be on? And do I really need all these standby powers? Can I wait 1 minute longer for my TV box to come on? Yes or no? Appliances, don't overfill your kettle. Fill up your dishwasher. Wash your clothes at low temperatures. Avoid using tumble dryers. If you have, if you're going to be drying your clothes somewhere in the room, then don't do it in the room you spend most of your time in, because humid air is cold and chilly air. So you effectively want to dry it in a room that you don't vacate that often, so you don't get that chilly effect. Use the devices obviously only as and when needed, so that comes back to the standby power. If you plan to refurbish, so thinking a bit bigger, thinking a bit more long term, think about energy efficiency aspects such as insulation, draft proofing, air tightness of the whole building, not just the extension. People say, I put an extension up, great, but I didn't consider the rest of the property. Or I've put lots of insulation in my extension, but then not really insulated the rest of my property. Bring that room to the same standard, right? Because otherwise you're going to spend all your time in your extension and you might as well, remove the rest of your building. Set yourself a long-term aim. Think about what you're going to do when. Easy wins towards larger investments. Think fabric first. That comes back to, air tightness and so on, insulation. Systems such as air source, ground source, heat pumps, mechanical ventilation units only really make sense if your property reaches a minimum standard on insulation and air tightness. Anyone who tells you differently just wants to sell because they're not paying the energy bill. You are. Aim for long-term solutions. So think about this in the bigger picture. What is your property going to look like, and how airtight is it going to be within 10, 25 and 50 years' time? I've read an article that says when you do a passive house build, make sure that you do the air tightness test as quickly as you finished, because after a year it might be horrible. And I'm thinking, that's a bad builder. I don't want that one. Right. So next steps. As I said at the start, doing something will cost money. Doing nothing is likely to cost more. Go home, think and plan. Think about what your quick wins are going to be, what you're going to do first, what you're going to do next. Think long term, what, when, how. Inform yourself, start the process and keep at it. Make sure, the problem for most people is, what tradesperson do I need for X, Y, Z? If you are better informed than your tradesperson, he might actually not quote for you, which is my experience. And that's the one you don't want. So, not your loss. We need to reduce our carbon footprint overall, so we need to do something. Not everything will come from the house. Some of it will actually come from behavior change. We might think, I want my property to do everything for me. No, you might not want to have that shower every 4 hours. And if it lasts 2 hours, you've got another problem. Yeah. So behavior change is not easy. So approach it in small steps. Start at key points. This is your New Year's resolutions. We like New Year's resolutions. It's a new start. It's a fresh start. That's what helps you with behavior change. Behavior change, once you've started to do it for about 6 weeks, you're most likely going to continue doing it. Yeah? So try and, hit that fresh mark. Thinking about making it competitive within your property and so on and so forth. One key message here, a lot of what we see is an electrification. Air source heat pumps, ground source heat pumps, etc. Electric vehicles. If you are going to electrify, make sure you've got green energy, otherwise you're not winning at all. Right. We will be providing additional resources. We are combining the questions that we are getting in these sessions. We will be sharing the recording of this session as well, and we will be providing additional material aside of that. All of that will come out after our last session, which I think is planned for the 19th of July. Now, we hope this is a start of a journey from our perspective working with the councils. We want to help residents where we can. Now, what we want from you as a return is you telling us what you want to see next. So we can target what is coming next a bit better. These sessions are very generic, but we really want to hear from you what you want to see happening. So, thank you very much for this. This ends me. Are there any questions?
You mentioned hydrogen and
Yes.
going into the gas system. I understand hydrogen is quite leaky for the gas main system. So, and the same percentage of gas going in, so hydrogen being mixed with the gas. And I understand we will still be able to use our gas boilers. Is that correct?
So,
whilst the mix is in.
Yeah, so the mix is likely to come from 2028, as I understand. Most boilers that are being installed nowish should be able to deal with that, mixed gas hydrogen. If you've got a boiler who's now already 20 years old, you may have a bit of an issue, although it might actually be a sturdy boiler, so I wouldn't be too worried. We all know boilers last about 10 years, so most boilers will be replaced by 2028. So I wouldn't worry.
I presume it's the burner that changes rather than anything else.
It would be probably the burner looking at and the control of the burner itself. So that would be the only thing that's really changing. But if we're honest, if we look at an old diesel would burn anything, so an old gas boiler will burn anything. It's the new ones you have to be worried about, because they try to optimize them so highly from an electronics perspective that if anything goes a bit out of shape, they get all wonky. And I'm an electronics person, I shouldn't be saying this. Any other questions?
I was interested in the mechanical ventilation, which hadn't sort of really come across before. I mean, can it be retrofitted? You sort of had a picture of quite a small diagram, and in the next picture it was a massive thing in the roof. I mean, what's involved in that?
So the challenge with mechanical ventilation is if you want to retrofit it, you have to think about how your pipework is going to go from your central unit, which in most cases would end up being in your loft. It doesn't have to be in your loft, it could be in your kitchen. There are even very small units that can fit into a full ceiling. But from there, you need to think about your pipework going out of the property for indoor, for air taking in, air brought out, as well as the pipework then going into all of the different rooms within your property. In the new builds, they will standardly use a metallic pipe, which is about 110 mil standardly. For most retrofits, they will use a plastic pipe, which is flexible, of about, I think there's 75 mil, which are the standard ones, and they've got 90 mil ones as well. So if you want to move down that road, you have to think about how your pipework is going to go. And that obviously then, fits in with your plan to retrofit the property. So I'm doing a retrofit in my property. All my pipework is going in for a mechanical ventilation, for an air source heat pump with different units. So I'm putting all the pipework in there while I am doing my property room by room. And that's me thinking ahead of where I want to be in so many years' time. Yeah. And that's what I recommend people to do when you're thinking about, starting that project. So you don't end up finishing it all and then thinking, oh God, I need a new, extraction unit here. And you can start opening it up again and, put all the pipework in, which is going to take you much more time, cost you much more, etc., etc. Yeah.
Where does the pipework go? Sort of in the floor space?
So pipework can go into your walls. Depends a bit on the property. If it's a more modern property, you've probably got wood stud walls. So you may nearly have enough space there. If you can replace one from standard 63 mil to 100 mil, you can put lots of pipework down there. Most modern buildings also have full ceilings. So again, perfect space to deal with that. If you've got an older property with solid walls, you may want to think about creating that compartment by creating a bit of a space against one of the walls to run pipework up and down, or into the spaces itself. Yeah. You first, I think.
If you don't have green electricity and you're thinking about cooking, or replacing a cooker, what's your opinion of electrical induction versus gas cooking? Or is there no difference in terms of efficiency?
Personally, okay, if you talk about gas or electric, if you ask any cook, they will say, I never want electric, I want gas. From a efficiency perspective, I would say if you're burning the gas, you probably have a slightly higher efficiency. Start to end than your electrical, because if I think about the production of the electrical, and if it's not solar or green, then I know I've already got losses before it really gets to my property. The challenge with that duality is, where is the gas network going to go moving forward? And does that mean that at some point, if I don't get gas anymore, how am I going to cook? Right? So personally, I cook gas currently, but I am thinking, do I want to cook electric? Because I may then work with solar panels and batteries, and I can basically provide myself rather than having to rely on an outside source for that. Yeah? So in the bigger picture, you need to think about where that sits. Again, comes down to how much cooking you do. Some people have a very nice kitchen but don't really cook much. So
you mentioned about heat pumps and Legionella, the flow temperature.
So standardly, heat pumps will efficiently give an output of about 40 to 45 degrees, which is why they work very nicely with floor heating or wall heating. Or if you're thinking about having to have units within the property, you have to have the enforced units with fans on it. When it comes to producing hot water, they will either, depending on the brand, they will either trickle and convert their cycles, so they actually play with their heat production cycle, which is a compression-decompression cycle, to go to a higher temperature, or some of them actually have immersion heaters within them. Yeah? So that's the two approaches you can find. Going to that higher temperature comes at a cost, as in less efficient, more energy going in. Yeah. There was one there, I think, sorry.
Yeah, sorry, going back to mechanical ventilation, appreciating that all products are different, but is it possible to give like a ballpark figure for that?
Right. So the units itself that either go in the loft or anywhere else, depending on whether you buy a more standard unit or one that's been certified for passive house, you're looking about £2,000–3,000, maybe £4,000 for the unit itself. And then you've got the pipe work and the installation, installation, not insulation. And that will depend on how many rooms you need to get to, how easy it is to get the pipe work in there, etc. The pipe work and the extraction vents or insertion vents, they aren't that expensive as such, but it's probably going to be the insulation cost then that you're looking at if you don't do it yourself.
Thank you. Mine is to do with the fact that I'm in the property business, I'm an investor and landlord, but I'm very hands-on. I've got a science background. So historically, over the last 30 years, I run the numbers, I understand thermodynamics, and I reduce energy losses. At the moment, the government is obviously disincentivising landlords from doing so because the EPC regulations have been brought in. The EPC has a very opaque protocol underlying it, which is only loosely related to energy loss. And it's really difficult to plan going forward. So at this point, I've stopped doing anything that's energy efficient because it's clearly a nightmare to do so because the government doesn't incentivise that. But at the same time, I can't work out what I should do to get through this hurdle so then I can start worrying about energy efficient in the future. Do you know, is there anywhere, and this isn't because I haven't been able to find it, where one can actually work out what protocol is to be able to model what one's going to do? Because the things they put on their reports are just garbage. And they also, they don't understand how energy works. It's like they don't care about surface area, they don't care about thermal difference. And most of the governmental advice, like turn the thermostat down, they obviously haven't tried experimenting with thermostats to see what is the difference on my comfort level versus activity rate versus actually don't heat the bit of the house you don't use, for instance. And the current systems which you touched on, the nest thing is greenwashing because it doesn't allow you to, if you've got anything more than one room, control the heat output in it. There are very few systems that do. There's Tado and EvoHome and so on. And clearly that's, like you said, it's one of your quick wins. Don't heat something that you then get energy losses from. But back to the EPC, do you know, is there anywhere where we can work out what the hell the protocol is underlying that so we can get past it?
So I would say to start off, I share your frustration in many areas, which is one of the reasons we're running these sessions. Because there's so much misinformation out there from a scientific perspective. And the bigger picture is often lost. Yeah. EPCs, I would agree, they're very much let's say, smoke in front of the mirror. Most EPCs are drafted very quickly. People who draft them don't necessarily have a full understanding of what the property is like.
What does EPC mean?
It's
electric and energy performance certificate. Yeah.
Brought in by the EU and mandated that the British government now has to produce them when there are property transfers and when things are let. And there are particular levels that in 2 years' time every property would have to be a C or above to be let.
Yes.
Basically, anything that's 1930s or onwards, it's almost impossible to hit it. So there's a big political problem coming. And the way they did it. So, for instance, for windows, the only options for the assessor is single glazed, double glazed, triple glazed, made after 2002. That's it. They don't care about the engine performance or the. So at the moment, it's incentivised me replacing some units that have gone to being triple glazed, even though their thermal efficiency is worse than if they were double glazed, because that will get me more points than I needed to make sure I can let this property in the future. It's totally nuts.
So the biggest challenge with EPC is that the people who actually do it have this very, crude way of classifying. Let me say it that way. I will need to get my property, re-evaluated from an EPC perspective, and I imagine I'm going to have to do the hard job and tell them exactly what I've got, because I don't expect them to know what I've got. So I think the biggest challenge is it's the people who are doing it have had their job simplified by a system that is as crude as you mention it. On glazing, there is, people often say, I've got sash windows with single glazing, I live in a grade listed building, what do I do with my windows? There is vacuum glass, which is about the thickness of a standard single pane, which has better U values than triple glazing. And so, you can have a perfectly nice sash window, which has got, standards as good as triple glazing. Obviously, your frame isn't that good, but that's a different story. So, yes, I know, I very much share that frustration. I'm not quite sure where the government's going to go with this, to be honest. I don't speak to
Just
them.
want to add something about this double glazing. There is a study in Glasgow, and they looked at single glazing with the shutter, a good fitted one, and it performed as double glazing. It's the same as double glazing, but unfortunately, EPC is a very conceptual kind of like a calculation method, and it doesn't consider all these the nuance of kind of like refurbishment. And I'm working with the City of London in terms of net zero, and they are going to use EPC, despite our kind of like a recommendation that EPC is not the best model, but it's very easy and it's a very conceptual calculation. It doesn't really show anything, and it's all based on predefined properties. We know that we're also fighting the same battle with you.
Just to contribute to the EPC thing, I'm actually going on a training course to become an assessor next week. But I do know, because I've been working in the world of energy efficiency for well over 20 years now, I do know that it's based on something called reduced level SAP, which was a very, very early, sort of 10, 20 years ago, methodology that was developed to standardise how you measure the thermal efficiency and the overall energy efficiency of a property. It was never designed to do the unique individual properties. It was meant to sort of give indications to people of whether it's more important for them to put thermal, insulate their walls, or whether it was more effective for them to put money into solar panels, and to give everybody a guide as to what the best things were to do, while raising the energy efficiency levels of our very poor housing stock across the nation. So I think they have improved it apparently in recent years, whereas the very original EPCs were very basic and didn't include some of the things which they now do, like I think one of them, reading some of the pre-course material, is the square footage of meterage wasn't included originally, but it now is. So they do move it over time, but it is what it is. It's just a very crude method, which, because you've got to find something that works for everybody, I think. So I'll just throw that into the mix.
Thank you.
Very good, thank you.
Being conscious of time, I propose we wrap up officially, but myself and Mohammed are going running, so we're going to be here for more questions anyway. So before I leave over to the councillor, would people please take a note of that address and give us some feedback on what you want to see happening next. As I said, we want to do more, but we also want to target that to what people want to see happening. And so we want your feedback.
Thankfully, smartphones you can log on now and do it in a couple of minutes. I've got open copies here if you'd like to do that. Thank you very much.
So I'm going to leave that up and leave it over to you.
Thank you so much. Vicky, Hannah. Thank you so much to Howard and Wim for fascinating. I mean, this is the second time I'm into it, and I've learned even more tonight than I did the first time. So it's a massive amount of information, but all of it very, very valuable for us all. And I think hopefully you've all picked up a lot of good stuff this evening, and it's really good that you've been able to do this for us. So a huge thanks to you two. Big thanks to the Council's climate team, to Vicky and Daniel for organising all this as well. And I just wondered, one of the things about this, what this kind of event is about communication. What we're getting here is a really powerful message on how we can do things better for our homes and for our bills, but also for our planet and for our communities. So the next step of the communication is to go out and tell other people what you've heard tonight, encourage them to come to our next event, which is going to be coming up soon, and be able to find it's there. In fact, there you go. So please tell people to come along to on the 3rd of July to the Millennium Centre in Brandon, which is a lovely, fantastic building actually. It's a wonderful church they've got there. So well worth going just for that alone. And get the communication message out there about what is possible. And the other important thing, and I think you heard that from both our speakers tonight, is about letting them know what you're doing and how well it's going and what more you need to know, and get that conversation going back and forth between what we're trying to achieve, because communication is the key. So thanks to everybody, and ask more questions.